Hi, this is Doug Lowen, Associate Professor of Public Policy at UNC Chapel Hill. This is the third part of my tutorial on bivariate statistical tests in Stata. Before we can demonstrate all these tests, we have a bunch of continuous variables, and I'm going to chop them up. Generally, this is not necessary. If you have a continuous variable, you don't want to chop it up. You want to leave the measurement scale as is, but just to make this tutorial go, I'm going to chop up these variables. I'm going to use a function or a procedure called xtile in Stata, and then recode. I'm going to check my results with the tab function and then drop a temp variable. So first I create a temp variable called pt temp. And then I say, okay, take this continuous variable called pupil-teacher ratio, and the number of quantiles is 2, so this is just a median split. So this is just going to create a high-low variable, a binary variable, out of this continuous one, and it's going to store it in pt temp. It's going to code low as 1 and high as 2. So I'm going to recode that because the convention for binary variables is 1 if yes or high and 0 if no. So instead of 2 being high, I'm going to say 1 is high and 0 is low. Okay, so this means that in the end I'll be left with a pupil-teacher binary variable in which 1 means high pupil-teacher ratio and 0 means low. Okay, so if you have any questions about how to use these particular functions in Stata, just type help, xtile, help recode, and it'll give you all the information you need. So I'm going to do that for pupil-teacher ratio, the child poverty rate, and then I'm going to chop the reading score up into 3 parts, high, medium, and low. I'm going to define a variable label called read label, where 1 is low, 2 is medium, 3 is high. And then I'm going to label the values. Again, if you have any questions about how to set up variable labels or something, just type help label. Lab here is just an abbreviation for label. Okay, then I'm going to check all my work, make sure I've got everything coded correctly by tabbing it out, creating a table with mean values of the continuous variable for each level of the binary variable. Okay, so I'm just going to highlight all this stuff and then click do, and let's look at it. Okay, I know I've already debugged this program, so I know there's no errors. So the first step is to create a binary variable out of the continuous variable and then recode it. It's always a good idea when you do recoding to cross-tabulate your variables to make sure everything it looks good. So the original variable pt temp is here. It's coded 1 and 2, but remember I wanted it coded 0 and 1. So I've recoded 1 on the temporary variable to be, 1 on the temporary variable to be 0 on the new variable, 2 on the temporary variable to be 1 on the new variable. So that all looks right. Again, we have 51 states. It's a median split, so there's about half in each category, not exactly half, but there can't be exactly half because there's 51 states. But then I drop that temporary variable. I do the same thing with the next one. Okay, notice that this one is a little closer. 26 and 25 in each category. That sometimes happens. Then we drop that temporary variable and we chop up the reading score into 3 categories, and then that we're just not gonna recode because it's 1 is low, 2 is medium, 3 is high. Okay, so we don't need to recode that one. We can leave it as is. So this is an ordinal variable, not a binary one. Okay, so we tab out our variables. We have about half and half in this one. and then we just make sure that it's pointing in the right direction and that we can interpret it correctly. So the mean pupil-teacher ratio for the one group or the high group is 17, and it's 13 for the low group. Okay, so that makes sense. We do the same thing for child poverty. The mean child poverty rate for the high group is 25% of kids in poverty. For the low group, it's 16, so that looks right. And then, as we can see, test scores go up as we go up in category from low, medium to high. Okay, so all our recoding looks good. I'm going to close out part 3 and then move on to part 4, which gets into the fun stuff, which is the bivariate hypothesis tests.